So we'll record it. And Michael, I can see your screen. And
Perfect.
let us get started then.
All right, so here we've got this case is actually in the module, so you can actually practice on it. And some of you've seen it before, so we're just going to recap a little bit on what we've explained in our videos. So what we've got is we've got a DICOM scan, and we've also got a model which we've made into a base with a model and with a model designer. And let us continue. So what we're going to do is we're going to open up 3D Slicer. We're working with 3D Slicer 4.11, and please make sure that you're using Blender 2.83 LTS and Slicer 4.11. Now I have already preloaded the DICOM into the scene. That's quite easy to do. There's a button there. You can click on DICOM and load that into the scene. So the first thing that we've got is we've got two add-ons in 3D Slicer. One is called the Slicer Link. It's one program which talks to the other program. Now, if you've got a big screen, that's really awesome to use, but even better I find is that if you've got two screens, most graphic cards, you can plug in another screen. In fact, some can plug in 4 or 5 screens. So it's quite handy to have two screens. Tonight we're just working on one on the Zoom. So the first thing that we're trying to do is we're trying to make a model. And the reason for that is because this white model here in Blender, we need to align that to our scan, our DICOM. And the way we do that is we make a little model and we port that into Blender, and then we use our alignment tool. And by doing that, we're going to get a good match. All right, so let's make the model. So in 3D Slicer, we've got a segment editor. So I'll just make this one a little bit bigger so we can see what's going on. And that's this little pen with this thing. That's called the segment editor. And in the editor, we can add certain segments. And so this is segment number 1. I'll call this bone. Okay, we call it whatever you like, maxilla or whatever you like. And then we're going to have a threshold. Now the threshold comes like in a slider. Now immediately you'll see this pop-up green with little speckles on it. Now this little slider here, we can slide to the right or to the left. Now what we're trying to achieve is a compromise between getting the threshold of the bone and actually having too much noise. So we need to get a balance between those two. So what I'm going to do is I'm going to zoom in a little bit, and then we're going to play around with the slider, okay? So usually around about 600 or 650 is quite good. So we're going to zoom through and we'll have a look. And that seems to be quite good, okay? So Wolfgang, can you think of any questions that you've got about this?
Yeah, so the question is, are you trying to contain these speckles or noise or whatever to the boundaries of the hard tissue, like the teeth? Are you looking at the teeth specifically to compact the green zone into that?
Definitely. So we're looking at a compromise, and here we can see a lot of noise, a lot of scatter happening, probably because of a metal crown or something. Sometimes it's good to actually only extract the teeth and not the model, just the teeth. And furthermore, we can even extract the sinus cavities, which is very helpful if you want to put an implant close to the sinus cavity so you can actually see it.
So Michael, what is the effect if you have too much noise or too little containment in the hard tissue? What is the effect on your segmentation model? You know?
Yeah. Yeah, that's a good question, Wolfgang. So you see all these little speckles, they become little models, like little bits and pieces of STL files scattered all over the show. So we don't want that. And if we make it too little, our actual model is going to be too thin. It's going to be like a shrunk version of a model.
Okay, so
So
it's
yeah.
kind of a resolution, or it sets the volume or the boundaries of your model that you're trying to create.
And every case seems to be different. I think it depends on the quality of the CBCT scan as well.
Mm, mm.
Okay, so once we've got that, we're going to apply that. Okay, and so this is going to take a little while to think. And while it's doing that, it's calculating, and then we're going to put it in Show 3D in the viewport. Now, in Slicer, you may not always want to see these little slices. We can hide them, and I'll show you in a second how that works.
So these colors, you can see the threshold being green. Can you set the colors to another colors, or can you make more segmentation models if you've got a powerful computer, I suppose?
Yeah, you don't really need that powerful computer. It's just, you know, while it's generating, it takes a little bit of time, depending on how big your threshold was. But over here on the left-hand side, we can set the color, we can name these things. So we can do quite a lot of things. So here it's appeared, and you can see it's actually quite dense. Yeah, it's quite a dense model.
Yeah.
Now, with this, I was saying that we may want to hide these slices, right? And in 3D slices, it's quite easy to do because we can go up here on this little icon. Sorry, down here there's a little eye icon. So we can hide slices as we go. We can link and hide all of them if we want to, and that makes them disappear. Now, I always think that we need to be simple. So for this ICP model, we don't want to export an entire skull because it slows down everything, computer, Blender, everything. So we're looking at small models, and this gives us the opportunity to cut these models. So,
So,
okay, we've
so Michael, the sole purpose of making a small model which we're porting across to Blender is because the coordinates of the CT scan, we need to match the coordinates of the model to the coordinates of the CT scan. Is that right?
Yes, that's right. Now, we'd like it to be small, but it is helpful to have a little bit of bone so that you can see where the implants are placed in Blender. So I'll show you exactly what I mean. We're going to click on the scissors and we're going to do some cutting. So I'm going to go erase on the outside. So you can select what you want to keep. So if we erase on the outside, I'll just draw a little line here like this. And we're going to take a little bit of bone like that, the mandible like this. Okay. Okay, we'll just wait for it. So what I'm trying to do is I'm going to try and reduce the model. Okay.
So does that reduce the file size, the data of the export?
Yeah, yeah. So you still see there's a lot of stuff happening over here. In we've got a thing like it says island. So you can keep the largest island and apply that, and it's going to get rid of a lot of clutter around it.
Oh, this is
Okay.
new to me. So every time I do this with you, I learn some new little tricks,
All
which
right.
is
So
good.
okay. So okay. So we can still remove a little bit more, but because you know we've got a time thing happening, we're going to leave this as it is. But I'm going to quickly, briefly mark the nerve. So in we've our second add-on is the slicer link, but we don't need it at the moment. We'll be using that a bit later. But we've got the panel as well. So I'm going to go to the slicer panel. And there what we're going to do is we're going to mark a like a line going across the lower, the mandible. So I'll just scan through midway of that, but we can hide this because we don't really need to see that. So I'll go back to the segment editor for a second and close the eye. And then we're going to go back to the panel. yeah, Pano, and we're going to then draw a little line going through the mandible. So let's just center this nicely. Up here, this little red dot, we're going to go to the open curve. Don't choose the closed curve, because that'll make a ring going around. So
what is the purpose of you drawing a curve?
the purpose is so that we can actually see through this, the slice will move through it. So I'll show you exactly what I mean. So we're going to select the curve, and then as soon as we move the slicer, the slide, it will move along. Now you don't see it over here because we've hidden it, remember? So we'll just open the eye, and here we can see how it moves along, okay, along the curve.
So it's like a perpendicular plane that moves along the line as such.
Yeah, yeah. All right, so what I'll do is I'll move back to where our implant site is. It's somewhere over here. But Wolfgang, what I do like to do is I like working only with one slice sometimes, because I find 3 slices is it's quite tricky to work with. So what I'm going to do is I'm going to select the green slice over here, okay? I'll hide everything except for the green slice over there. And this one I can then move around. See, so that's a single one. Okay, and we're going to focus now on this one here, for example. And then I'm going to move that through, and then we're going to angle this like something like that. Okay, usually it's around about 90 degrees. Okay.
So this is a tangential angle, so you can see it from the side.
Yeah, so then what I'm going to do is I'm going to move it like that. Remember, we're using the green slice over here, okay? Now, the purpose for this is because I want to see the canal running across like it, which I've got a perfect view of it. So as I'm moving the slider, we can see this quite nicely. Okay, here we go. Okay, we can just move that a little bit still. So this takes a little bit of practice, okay? It's, yeah, okay, so there we go. So what I want to do is we want to mark this, okay? So I just want to move this across a little bit more, maybe like that. Okay, that's good. We can see the exit, and then we can see it going all the way, stretching across. Okay, we're going to go back to the segment editor, and in the segment editor, we're going to add another segment, make sure it's selected, but this time around, we're going to draw tubes. Okay, click on that, and we're going to set the diameter to say 1.5. You can set it to whatever you want, and then we're going to grab one of these points. And then while I'm doing with the mouse wheel, I'm going to look for the exit, which is over there, and then we're going to mark over here, and then we're going to bring it all the way across like that. Okay, and then we're going to right click, and then we're going to apply this. So don't forget to apply this. When you apply it, it goes, all of a sudden it goes solid. Okay, we'll just wait for this. Okay, it's gone solid, and we're going to call this nerve. Okay, and then what we're going to do is we're going to export both of these. So export to file. I'm going to select this, and I'm going to go. Make sure you click on RAS. This is the most important thing you have to do. Okay, otherwise it takes on a different coordinate system. Okay, export. Okay, are there any questions? Maybe Wolfgang, can you open the microphone so we can maybe answer some questions?
Open up the mic. So if you've got any questions on this part with the nerve or the tangential or transverse plane, feel free to ask, or the segmentation model that Michael's making.
Okay.
All good to go.
All right. So I'm importing it. I'm just waiting for it to come into Blender. Here we go. And this is the coordinate that we're looking for. Okay. So we've got the nerve over here, the tube over here. Actually, what we can do is we can give it a color. Let's mark this. Let's mark this bright red so we know it's a no-go zone. And so, okay, now what we're going to do is we're going to align it. So in Blender, the alignment add-on, it's actually quite simple how this works. So what I'll first do is I'll rotate it a little bit, use the G and the R key. And the reason why I'm doing that is just so that I can see that the landmarks are the same that I'm putting down. You don't have to do that. If these are visibly clear to you, you can proceed. Okay, so what we'll do is this is the moving, okay, and then this is going to be our destination, and we're going to then place a few landmarks. Okay, so place landmarks, and I'll plonk one down, say on the molar like that. And so what I'm doing is I'm looking for common spots which are semi-okay. So number 2, let's plonk one down here on the canine here, and maybe one in the back somewhere
The Blender session here.
like that, maybe. So it's 1, 2, 3, 4. All right, so I think that should be good enough. Okay.
Einladung geschickt.
Enter, and then what we're going to do is on the destination, place landmarks. We're going to do the same thing, but make sure that you get this more or less the same spots. So let's put one over there, one, and then we're going to put one on the, I think it's on the lateral there, like this, and then on the canine.
So Michael, just a question here. When you're placing these points in the back of your mind, are you considering the axis in which these points go, like a vertical or the horizontal axis?
Yes, Wolfgang, because if you think of a plane, like like just a sheet of paper, and you would put like 4 points, and you have another sheet of paper, flat paper, and you put 4 or 5 points, or whatever. What can happen is that these will align each other, but one of them will flip over like that.
Yeah.
Yeah, so I've seen that happen. So you want to try and lock them in somehow if you can on the X, Y, and Z axis. Okay, so we're going to select both of these and perform our initial ICP. Okay, so that's just placing it one on top of the other in a semi-okay.
So
But don't rely on this.
This alignment wouldn't be good enough for, other like scan bodies, for example. We would have to keep on going until you get to the end result.
Please do, yeah. So what we're going to do is we're going to perform ICP alignment, okay? So now it's thinking, it's doing its slight movements here and there. You can actually see it move. We can take this one step further and we can refine this movement if we want to. So, but I think we've got quite a good alignment, but always inspect this, because if you don't, then you may be drilling into the nerve when you're doing, so this is very serious. I have seen someone not do, we've caught it in time, but we need to make sure that we've got a good, quite a good alignment here. Okay.
So as a backup, you would check this on the CT scan anyway. You would verify your locations.
Correct. And we've got a color map. If you want to use a color map, it won't be such a good indication because a lot of, like the model here is all offset. So the blue is touching and the red is offset, but that's well, quite clear.
We've got a mucosa in there that hasn't been considered here.
Yeah. So if you want to get an even better alignment, click on refine proximity. So what that does, it takes the the vertices, and then it matches them with the other vertices in the immediate vicinity. I think it's 0.1 or something. And then it will take those in the calculation, and then it will do the ICP. So here you'll see slight movement as well. You see it's just slightly moved, and this is quite good. Okay. So if there's any questions on the ICP, I think this would be a very good time to ask.
I've got my eye on the message window, so feel free to type away and I'll relay the question to Michael as well.
Yeah, so just one little question about the refine proximity function. I see that the button is on top of the perform ICP, so we are forced to click on it before performing the ICP. Should not it be behind the perform ICP on the bottom? So first you perform the ICP, after you refine, and after you redo the ICP. Do you know what I mean?
Yeah, I know what you mean, but usually we don't have to refine it. So, you know, that this is why it's in front. I don't know why it's taking so long. I'm actually working on my laptops because my computer's in the repair shop. So let's just see how this goes. I don't know why it's taking so long. Okay.
So in fact, this type of function, you only use it with the scan bodies alignment when you really want some very, very geometrical alignment?
So can you just repeat that question?
The refine proximity, I see it on the tutorial that we use it when we perform the scan bodies alignment for an implant model. And with this type of function, we can have really very precise alignment between two geometrical objects when we have the component from the library and the component that has been scanned into the mouse with the iOS. I think that on this special case, you should do the refine proximity because you will have a much better alignment. But when you are working with two models like this that are really not quite similar, that in the same space but not very similar because it's not the same acquisition, I think that we don't have to put a refine proximity. So I understand.
Yeah. So there's something not, I think my laptop's not coping very well here at the moment. So what I'll do is I'll just pass you over because I have saved this version. So, and then we're going to continue in just a second. Okay. Oh no. Okay. So it's done it, but it's taken a very long time. All right. Okay. So we're going to continue and we're going to now port this across so that we can match it accurately. But before we port this, what I want to do is I want to just open up a collection and the outliner. So it's important to get to know your outliner. We're going to move this one into the a new collection, say ICP. Okay. And I'm going to hide this for now. You can delete this model because it's saved on your computer anyway. But, you know, because we're thinking about the efficiency and speed of Blender all the time. Now, this one is like 1 million vertices. That's like 4 or 5 dental models. So we need to always consider the, you know, the speed of our work. I have seen people put in like 3 skulls, you know, the same skull, but like 3 times. And it was like, you know, it was very difficult to use Blender at all. So, yeah.
So can you explain the purpose of porting this across like a once-off transfer? Why do we do this?
We do that so that, you know, the porting is easily done with implants, but when you've got a huge model like that, it's going to get clogged up. So we don't want to clog up the system. I have changed the coding a little bit so that you don't actually have to worry about that anymore. It will only take your implants into the porting unless you select it and port it, like I'm going to do in a second. But we do want to see where the teeth are, and this is also important because we want to see where the implant comes out of the bone. So what we'll do quickly is we're going to import a few hollow teeth, and we'll put them into the gap. Okay, so this is a hollow tooth library. I'm going to choose the two teeth, this one, and delete the unwanted teeth. Then we're going to select all of these teeth and plonk these into the gap. Okay.
So, Michael, can you explain why do we use an open tooth library here and not a closed tooth library?
Wolfgang, that's a good question, because a closed tooth library would actually intersect through into the model. And when we port things through, you don't want to have any mesh or anything interfere in the view of your implant planning in the DICOM. So this is why we want to have this above the gum, above the tissue. Okay. So I will,
the workflow
yeah.
will always follow the same. We have to get the teeth into position because the teeth will ultimately guide the position of the implants. So we can sort of predetermine the angles and things like that by putting the teeth in first.
100%. Yeah. Now, we do want to see these being a little bit transparent, because then we can actually witness what's going on with these implants. So I've set the transparency a little bit. This one as well, I'm going to add a little bit of a color to it. And we're going to set the transparency as well. So to 0.8 would be quite good. Then what I'm going to do is I'm going to select, we're going to have to open up the port, okay? So don't forget that. So in 3D Slicer, we're going to go to dentistry and we're going to click to the link. We're going to open up the server and we're going to connect this one up. Now we've got freedom to port things across to the other program. So I'm going to select this one, and this one, and we're going to click on one-off transfer. And we'll just wait for it to port across. And the next step is crucial because you need to check that the model aligns nicely with your DICOM, which it should be doing.
So at this stage, is the model locked, so you can't move it in Blender?
Well, that's at the moment we can't select it. So there's nothing in the scene. Well, this one we can select, but yeah, you can lock it. It's a good idea to lock things. If, because often, it has happened by mistake or whatever. You can move things by mistake, and this is critical. Wolfgang, good point. But at this stage, we can't select it at all because it's in a collection which is disabled. You can't move it. All right, we're going to just quickly have a scan through and see whether this has been nicely aligned. Okay, so I'm going to roll my mouse wheel and have a quick look and just see. And a good way of telling is here if the boundaries of the DICOM are nicely outlined. So if I click on Shift and move the mouse, I'll be able to see the cross sections as well. So we've got a very good alignment here, I can tell. Okay. So this is very critical to the success of your implant surgery. Okay. Okay, now what we're going to do is we're going to put implants in. Now we've got generic implants, or you can use the implants that we have in our website. Wolfgang, can you explain more or less, what types of implants we have at the moment?
Yeah, so we've got one of the big ones is the Medentica. They have a beautiful range of implants. J Dental, Italian company also, and we're growing the implants. You can access these through the component module. There's other ones, some Camlock and IPD, and the list goes on. It is growing. So through the component implant crowns and component module, you'll be able to search through the search fields, and you'll see a thumbnail image. And when you press on the thumbnail image, you get more and more implants showing up. And then you make your selection and press the append button. So when you press the append button, the component will be imported into the Blender 3D workspace. Now with a lot of the implants, I have pre-assembled those into like assemblies. So you'll find that the scan body and the analog are linked in an assembly. The abutment and the connection geometry that will make the crown will also be in assembly. So in this way, we can shortcut all this. A lot of time is saved by having to have it all together already in pre-assembled parts.
Cool. Yeah, thank you, Wolfgang, for organizing them in this way, because you know these some of these implant companies have lists and lists and lists, and for us to search through these lists is just, you know, it'll take you the whole day, and you've done this for us, which is fantastic. You know, so yeah, thank you for that. All right, so I've exposed my ICP model. My ICP model, I mean my DICOM model. And what I'm going to do, and you can print this model as well if you want to, by the way, because it is an STL file after all. So what I'll do is I'll just go into cross section, and I just want to see how much space I have more or less, you know, between the, you know, in the cavity. So I've got a clear visual of my nerve, my tooth and the bone and whatever. I can make a quick, you can measure in the 3D slicer if you want to. We've got some tutorials there, or you can simply even measure in Blender. We can see, okay, I'll take a measure. Okay, sorry, I've just got it. Okay, so we'll just take a measure here, and it's like, well, 10 millimeters, you know, and let's just take another measurement, 5.5. So we're looking for an implant round about that vicinity. So I'm not a surgeon, and I'm not telling anyone how to do this. So please take note. You know, this is a hypothetical way that I'm doing this. So, you know, I stand to be criticized. All right. So what we'll do is I've got, we'll just get out of this one, Alt B. I'm going to take a short implant because I've measured 10 millimeters. So this one is a micro cone RI, which is, I think it's 8 millimeters in length. So yeah, so what I'm going to do is I'm going to append this into the scene like this. And the first thing that we're going to do is please do not move this, because the algorithm searches for certain things. It searches for the top and the bottom, and then it places all of the components that we need for making this guide. So at this stage, what we can do is we select it, and we in the guide module, we're going to accept it. So we've got accept your implant. Okay, so this color codes it blue. The other ones are color coded yellow and green. These are our generic ones. So if you don't have, and if we don't have your implant system, Wolfgang, can you explain, you know, you've made a video of how these components work, you know, how people can make their own.
If you want to use your own components, that's okay. Just follow those two videos. In the back of the implant name or code name or product name, whatever you want to call it, you have to put certain suffix names like analog sleeve or just sleeve or scan body, and our coding will pick up those names like analog sleeve or implant and things like that. So just by adding suffixes on the back, it should be functional. Some of the components need a bit of adjusting, where we have if we're making an implant model, we are given the mesh geometry of the hole, and we actually have to convert that into an object first. But yeah, the video will guide you how you can include your own implant components. If you can get those in an STL file format or even OBJ file format.
All right. We've got this implant. You may think of, what is this red thing? This is the safety zone, which is 2 millimeters standing away from the implant. You can change that. You can take it away if you want to. So, or you can add a bigger zone if you want to. You can't select anything else. Everything else is locked except for the implant at this stage. That's just safety, so we can actually move it. So the first stage of moving this is we're going to put this into a hypothetical placement. So we're going to use G and R key to rotate, and we're going to put this one down and move it into the place where we would think it sort of would go in. So let's sink that in there like that, and we'll move it like this, maybe a little bit. I'm going to use Alt B to get a cross section of this, so we can get a clearer view of what's happening on the inside. Okay, I'm going to use the R key and the G key to grab, and we'll hypothetically place it into the bone. And then we're going to double check this then in our DICOM software. I'm making sure the nerve is quite far away at this stage. Okay. Now, to speed things up, I'm going to duplicate this one. So duplicate, selected implant. You can't do Shift D. Shift D is duplicate in Blender, but it's got all of these components with it, so it's not going to work. So duplicate selected implant. It'll shoot another one to the side. Okay. Make sure you've got the correct one selected, and we're going to grab this one and put it in the position. Again, I'm going to use Alt B is very good because we'd like to see cross sections. Now, if you'd like to,
here's a very good question. Can you open 2 Blender windows so you can see the implants from different angles?
yes, you can. You can. It's similar to the diagnostic model. So you've got this one, N and T to get rid of that, and then we can view it. You see, one's in cross section and the other one's not. So you can open as many windows as you like. So it's actually very handy to have this because you can sort of visualize what is going on. So if you wanted to have a longer implant there, you can just place a different one. And we've got a tutorial explaining exactly how you can swap from one implant to the other. Okay. So knowing now we've placed it there, and chances is it's in a good placement, it's in a good position in our 3D slicer. Okay, but just to we've got to verify that to see whether this is in fact true or not. So I'm going to zoom in and shift and then move your mouse to actually view what's going on. Okay, so here we've got one, and then we've got the other one over here. Okay, so already that's looking okay. I won't comment whether this is this indeed is the best placement. It's not for me to do that. But if you wanted to move these things, you can. We've got this control box here, so you can click on that and then just move this up and down if you wanted to. So this is very handy to have. Okay, so I'm actually looking at the wrong implant here. So, okay. So you can move this up. Here you can see over here how it's moving. Okay.
So instead of using the G key and the R key on the actual implants, you're just using those arrows and that.
Yeah, this is just for fine tuning.
Yeah, just incrementally it moves it. Mm-hmm.
I think it moves it by 0.1 millimeters. It's like 100 microns or something. Yeah. So you can rotate it a little bit, you know, this way or this way. You can fine tune it nicely. Okay.
So you're looking
or
at
alternate.
Oh, sorry, you're looking at the upper occlusal table as well while you're doing all of this.
Well, yeah. So yeah, we need to take that into consideration, you know, as well. But of course, you need the best implant site where, you know, where it's going to integrate the best way, you know. So we can always add an angle if we wanted to. So yeah. Okay, I won't get into the angle right now because we may just run out of time. So I'm going to close this up now. We're assuming we are okay now. Is there a question?
No question.
No question?
No.
Okay. Okay, I'm going to hide this model and we're going to continue now with what we need to do.
So Michael, you were saying there's an angle indicator and one can then use that then to later cut the hole in the crown, can't you?
Yeah, you can. So if we wanted to add, say, for example, an angle on this one, we can click on this button here, create abutment angles, and then we can shift this angle if we want to the correct here, yeah, the x-axis, yeah. And then, you know, if you've got like a 7-degree angle, or for example, you know, you put 7 degrees here. This one is supposed to be 0, and you can then put an angle in there if you want to. Okay. Okay, delete angles. All right. So the next thing we need to do is we need to accept these implants. Okay, so we finished with our DICOM. We're going to go to the create sleeves, and we're going, this is where it all starts. You're going to click delete zones and start. And okay, for this video, I'm going to just hide these teeth. Okay, so we are prompted with the tooltips. If you get lost, look at the tooltips. They appear for 200 seconds, which gives you ample time to make your next decision. Okay. So it tells me to set my drill diameter. So I don't quite know what the drill diameter for this specific one is. Actually, let's place one of the sticker sleeves in one of them. So we're going to, for this one, we're going to actually make, so don't be alarmed that this places it all the way to the bottom. It's part of the procedure because we're going to measure our offset. So just say, for example, my drill diameter is 4, I don't know, we'll just put a random number in there, or actually maybe a bit thinner. We'll just put 3 for now. And then what we're going to do is we're going to focus on this offset. Now, a lot of implants have a 9mm offset, so I believe. So if you are flexible with your offset, you can actually use this arrow key, and every time you press it, it goes up 0.5mm, okay, up or down or whatever. So if it is 9mm or 9.5 or whatever you have, key in your offset in the Z over here. And then what we're going to do is there's 2 ways. We've got a new button here. It's auto hole in sleeve. So that would skip all of these specific ones. So that's like 4 buttons that you can skip, assuming you want to have the defaults in there. So let's first do it without, but I'm going to save my work. Okay, always save your work as you go. So to explain, this is the drill clearance. It puts a 0.1mm clearance around it. You can adjust that. So if your drills are too tight, you're going to put a bigger clearance. If they're too loose, you're going to shrink it. So that depends on your printer and your resin and so on. So we're going to apply this, apply that, and then we're going to trim the drill. It's going to cut it off exactly at that spot, and we're going to make the hole. Okay, so that one is finished. Okay, now we're going to do the same with this one, but we're going to do the auto one. So we're going to do the same one like this. Set this to say 3. always make sure that the X and Y is the same. Otherwise, you're going to have an elongated elliptical shaped, and which we can't have. So it needs to be round in diameter. Okay, so we're going to put our offset, so it's say 9 millimeters or something. So here we can see it's pretty deep, you know. So if we have a 9 millimeter offset, we need to make the sleeve a little bit small, thinner, or we can leave it like that and it'll be cut off anyway from our cutting when we finish it. But okay, so we're going to go S, Z, okay, and then we can scale this if we want to as well, you know. But make sure that the Z is between 5 and 6. Don't make it longer than that. Okay, now we're going to click auto hole in sleeve, which will bypass all of that. So that will speed things up tremendously. Okay, so are there any questions related to this so far?
I'm just thinking about the undercutting areas. Can you explain how to tackle that?
Yes, Wolfgang, that's a good question. But before we engage in that, let's put a metal sleeve in there, because you know, we've got the Stecco from the company in Stecco that sell these sleeves, and these are very good. Maybe you can explain a little bit about these.
Yeah, so the sleeves, often when you get sleeves, they have retentive grooves for cement retention. And what we've done is we've created cutting tools out of our Stecco components, which is we've taken all the undercutting areas away. This is because we've seen that some users struggle with fitting these metal guide sleeves due to those undercuts. So when Michael imports it, you'll see it's got flat parallel sides, and it's got no retention in it, which means it should slide in. And furthermore, we can offset that area as well. So if you find your sleeves are too tight, you just increase the offset slightly.
Now I've used a random one. I've just picked one that's that this isn't MIS, but there's a whole list of different ones that you can pick. So we'll just pick one randomly, and we're going to append this into the scene for now. Now, what we're going to do is, this is just a cutter. It's not the sleeve itself. And we're going to, with this being selected, we're going to select where we want to place it. And then in the guide module, in the third menu section here, you're going to click select and place insert, which puts it exactly into our sleeve. Notice now, please, that if we cut this and you want to print something this thin, good luck, because it's, you know, we're looking at like 0.2 or 3 millimeters. So be consciously aware that we have to then put a little bit more plastic. I mean, it's not critical that it has to be 1 millimeter or 2 or whatever. Make sure it's sort of 0.8. You know, you get the feel of it very fast, how these dimensions work. So SZ, we're going to make this a little bit different like that. And then I'm going to select this and make the hole in it. So I've selected it, which then expands it by 0.1 millimeter. If your sleeves are too loose or too tight, this is where you're going to change your clearance. So it's very important. So we've got the capability of changing that, okay, and apply this. And this will remesh it, and we're going to make a hole.
So the Stecco guide sleeves are usually around 5 millimeters long. So in this specific application for this sleeve, you would find that the metal sleeve is a little bit long. And Michael, that would have to be cut then. Alternatively, we could have set the offset a little bit higher and then make it longer. So
the good thing about our add-on is that our sleeves, you know, the metal insert sleeves often have a little lip on it, which is like 0.5 millimeters. Sometimes it's a little bit thicker than that, which actually will muck around with your offset, because you can imagine we've selected 9 millimeters offset. Now all of a sudden you're putting a metal insert with a lip around it, which does not engage fully. With ours, you can see how it's been inset like this, which means when you put the metal sleeve in it, it's flush. It's completely flush with our sleeve. So that means 9 millimeters will be 9 millimeters. Okay, so if there's any questions, Wolfgang, can you open up the microphones maybe?
Yeah. No, we're all good, Michael.
All right, so that's good. Now, we've done everything we need to do with these implants. We have to focus now on the guide. How much time do we have left, Wolfgang?
Well, maybe 5 minutes. 10
5 minutes.
Maybe.
Yeah, so the thing is, we've gone very much in detail with everything. So yeah. Okay, so the next thing is we need to block it out. I'm going to put a bit of alpha value to this. We're going to go to the block out menu. This becomes our lower. So I'll just go through this very fast. Create our offset, apply.
So what is the reason for the offset in the blockout module, Michael?
Well, if we're making anything fit on, especially printing, we need a bigger model so that it fits nicely. So we're going to survey this lower, and I'm going to get a good path of placement like that. And then what we're going to do is we're going to create a passive model. So it's just going to think for a little bit. It's got all of our beautiful scripts doing the thinking.
So the passive model, can you just explain what is a passive model in this situation?
Well, all of the undercuts have been blocked out.
Yeah.
So when you put this guide in, you're not going to struggle fitting it. It's very important. There's a few softwares that don't even use a blocked out model, which I find very bizarre. So, okay, we're going to finish this passive model. You'll notice how it's jumped. That's because we have tilted the model and then it's flipped it back to the original position. Okay. So here we see it's a nice model with everything is blocked out. Okay. Now we're going to go to the, so it's good to lock these things. Okay, you can see why. So with this in mind, I'm going to be selecting this and I'm going to rename this. So in the guide module, we're going to go to the, Wolfgang, should we paint on a layer or should we make a tube?
I don't know.
Maybe make a tube.
Whatever. What should we make? Maybe put it to our audience.
Yeah, good question. You know, there's a choice. We can one or the other.
Do a tube. I'm not good with a tube.
You're not good. Okay. Let's call this target model. It turns it white. Shift right click to place your cursor where it starts. Draw tube, and what's happened? Are you there, Wolfgang?
Yeah, I'm here.
I've got a crash. But I did warn you because I'm working on my laptop. Yeah, we've just had a crash. All right, so I'm still here. Yeah.
Yeah, you're still here.
Okay, I've got to find my way. So I'll just stop sharing my screen just for a second, eh?
Yeah, no worries.
Okay, I think this is too powerful for my graphics card. Okay. So yeah, I've just got to go back to the blocking out.
Yeah.
Okay, share screen. Advanced. Can you see my screen?
Not yet. Yes, yes, we can see it.
Oh, I'm just going to fly through this quickly, okay?
Okay.
Okay, so this is lower. All right. Finish that. Okay, so this step is very important. Just go through this. Survey this lower, like that, and make a passive model, create passive model.
So Blender has an auto-save feature where you, if ever it does crash, often you can get back to the last scene that you were just working on.
It's a good idea to set it to like, well, I think by default it's set to 2 minutes. So you can set it to 1 minute or something as well. So, or just save, you know, save after each crucial step, which I should have done anyway. But okay, so okay, we're back here. We're back here. So we're back online, which is good. All right, so this becomes our target model. We're going to call this in the tube section. Tubes, target model, okay. And we're going to shift right click to place our cursor. I'll just save this.
Save it. Here's a good question about retentive surfaces with a tube. Is it not better to have a closed design rather than a tube design for fit purposes? So, well, it depends. I mean, Michael, I think you can cover quite a bit of area to make sure the tube will actually fit well against the teeth. So it still has a bit of retention. Hey, Michael?
It's got, well, the ones that we've printed have a lot of retention.
I think it's,
and
sorry, yeah, keep going.
Yeah, and also you don't have to go through the top. You can cut straight through the teeth as well. One of our users always cuts all the way through the teeth, so you've got like a bracing. It sort of braces.
Can you demo that on maybe one of those tubes?
Yes, yeah.
Yeah.
Or alternatively, you can even have a combination of a layer and a tube.
Oh, so different, yeah.
I can actually demo that.
Yeah.
Okay.
I think that the tube does offer a very good irrigation though.
Well, yeah, that's right. That's correct. So if you wanted to do plastic printing, make it quite thick, you know, if you wanted to do metal printing, you can select them all and Control A to make it smaller so that you can do like a metallic, laser printing if you wanted to. So that's all possible. So okay, let's make a combo. You know, I don't mind. So we're going to apply this. So we're going to remesh this tube. Okay, and we're going to accept this tube. So voxel's thickness is 0.4. We can make it finer if we want to. And so what we'll do is I'm going to then make sure this is still target model. We're going to go to the paint paint on. So create sleeves here, paint on layer and paint on. Okay. Just wait for it to come up here. Okay, so let's have both versions.
Yeah.
So we can extend this even like that. So we are very flexible. I mean, it's the creation is completely up to you what you want to do with this. All the tools are there. Let's put a dot on here, for example. Yeah, that's cool. All right, so what I'm going to do is we're going to then accept this, accept layer. Okay, and then we can smooth it if we want to, which is a good idea to smooth because we're always thinking of the geometry of how this is going to print. So we try not to do too many shortcuts. Okay, exit. Okay, and then we're going to finish this layer. I'll also make 0.3 and finish it. Now we want to join them together, right? So this one, shift left click to select the other one, and we're going to join them. Now in the guide, well, you can use Control J, which is the shortcut for joining, or you click on this one, join. So that's joined the two, but then we have to remesh it. So we're going to click remesh, and we're going to accept that. So now we've got a combo version. Okay, layer and a tube. Okay. So there's a whole lot of things we can do. Okay, so here we could have come a little bit closer. I'm thinking, oh, well, what do I do now? Okay, so I'm going to go into edit mode. I'm going to just click here, make sure the proportional editing is on. Use the G key, and with a mouse wheel, just pull it across. Just put it in there like that. That's all good. Tab. Okay, perfect. All right, so the final step is finishing it off. So we're going to go to guide finishing, and we're going to expose our cutters. These have been made behind the scene while we were working, and we didn't even know about them. Okay, we're going to, because we've had a metal insert, we need to scale this, okay? So we're going to scale this like that, perfect. And this one is okay. We can scale that one as well a bit if we want to. Okay.
So this cuts there into the guide layer or the skeleton guide.
Yeah. So here's the thing, you need to select which ones you want to use to make a cut, because what it does behind the scene, it duplicates our selection and it makes cutters. Okay, this is just a visual exposure of our cutters. So I'm taking the one, shift left click to select the other one. Let's save, file save. And you need to make sure that this is called layer, otherwise it's not going to cut. Okay, so if you're working with 3 different layers or 4 different stackable, you need to make sure it's called layer. Alternatively, you can use the select object being cut and manually select them. Okay, but for now, I'm going to take these 2 and we're going to cut holes in guide layer. Okay, so I'm going to check, and that's perfect, nicely cut, and we're going to expose our guide cutters. Now these are the ones that clear way for surgery. We want to make sure that this doesn't stop anywhere. So I'm going to take this, scale this outwards. You scale it as big as you want to scale it. And then this one we don't really need because there's nothing to clear away. Okay. So I'll select this one, and then we're going to clear guide layer. And you see it's made a cut, it's made a wedge in there. Okay. So that's perfect. Okay. Now there's only one thing left to do, and we need to cut the fitting surface of this. So again, it needs to be called layer. It actually says layer minus target model. That's just a reminder. So you can manually select it. You can select this one and then do this procedure there if you wanted to. So cut fitting surface. Okay, I'm going to hide it and see that it's cut. If you've got a Boolean failure, then go back, remesh this one at a different voxel size, which you can do over here, and then do the Boolean cut, because we are reliant on these computer algorithms to make a good job. But every now and then you can win the lotto, and you've got one vertex out of 1,000,000 touching another vertex out of 1,000,000, and these 2 vertices don't like each other, and it fails. And then we get a call, oh, this thing's failed,
Yeah.
team viewer.
Yeah, so you would just rescale it or remesh it, would you?
Correct, yeah,
Mm.
okay. So finally, I'm going to select my components that I want to use, and then we're going to export them, file export
For printing.
STL. This is vitally important, selection only, okay, very important.
Okay,
All
I've
right,
got
I
a,
think
I've got a
that
really good
completes
question
it.
here, and I don't want to ambush you, Michael, but are we able to put into the implant an abutment that we can use as a temporary?
Oh, to make a temporary.
Yeah, so now that we've got our implants placed and all that, can we use our abutment to put a temporary on there?
Yes, we can. Yeah, yes, we can, because these implants have a coordination in Blender. These are the coordinates, and we can match any component that we want to into these components, into these implants. Now, which one did we select? I can't remember which implant we selected. I think it was just a random one or something.
Yeah, it was a Medentica component.
I can't, I think it was, I can't, it was an RI, microcone RI. So we're going to go to Medentica abutments,
Yes.
and we're going to look for, maybe you can help me out, RI, DC. I think maybe I'm in the wrong section or not.
Yeah,
Oh, that's Southern.
Southern Implants.
Okay, Medentica
Yeah,
abutment. And we're looking for the RI, isn't it?
Yes.
Is that the
Yeah.
R here?
Yeah, just one
RI, yeah,
Yes.
quadricone. So RI, okay. So this must be the list.
Yes. So if you
Yes.
just take one of these, just randomly pick one, just as an example.
Okay, so we're going to append this into the scene. Okay, there it goes. There it goes. And then we need our component module, which is over here. So this is our abutment. So in transparent mode, we're going to select our abutment, which is the outer layer. B, box select to link it. And then we're going to link abutment assembly. Okay. And because we've got two, we might as well just duplicate the one, isn't it, Wolfgang?
Yeah.
Okay. So so we've got, where's our duplicate? Copy assembly. Copy assembly. There we go. Okay. Now what we're going to do is we're going to, this is our destination. Okay, let's click on this. This is our destination. Select destination. And this is going to be match position to destination. Oh, there we go. So let's do the same thing. So this is our destination. Select destination. And then this, we're going to flip that one into the other one. Perfect.
Okay.
Excellent.
And now
Well
can you
done.
put a crown on it?
Yeah, okay. I've got to look for my teeth. Let's have a look for my teeth. Okay. Here, wax up. Yeah, teeth. Here we go. All right. Let's hide everything else so we don't see it. Because okay, so hide this. H to hide. Okay. Okay, so we've got that one. I think I've got a bit of a slow computer. I think it's got too much on at the moment. So edit fixture margin, and I'm moving that up a little bit because you can see how, yeah, no, actually, yeah, we can this because we don't want it going other way around, right? So I'm going to make sure proportional editing is on, and we're going to use the G key, and let's move this margin up a little bit like this. Okay, like that. Okay, maybe even yeah, I think that should do it. That should do it. Okay, so this is going to be my fixture. Select a name fixture, and this is going to be my abutment and create collar. Okay, here we go. So we've got a join. So we've already got a crown, Wolfgang.
Yeah, that's
How
excellent.
cool! How cool is that? But we may want a hole going through that crown as well, don't we? So with it being selected, select fixture and create hole cutter. Okay.
Yeah.
So we've got a few cutters on the scene, but we don't need this one. This was one that we used earlier for our guide. So this is the one that we are interested in, right? So we're going to then just have that one selected. And then what we're going to do is select each component and make a hole. Okay. So here we've got a hole in our
Excellent.
crown. And this one then you can print. So let's just have a look at it.
Yeah.
Okay, there we go.
And the other question was if we can add a scan body of the root. Well, that would follow the same process, wouldn't it?
It's the scan body of the root.
Yeah.
Okay. So just a mere scan body, is it?
I think we're talking about the root, trait root implant system. But you do exactly the same. You'd select the destination and match position, and you'd be able to get the scan marker into the scene. It would follow the exactly same process.
In fact, you can take any object and it'll do the same object. You can take a cube or you can take whatever, and it'll snap it exactly into that location, because it looks at the point of origin, which is that little orange dot. That's the point of origin, and in Blender space, that point has certain coordinates. So whatever you snap to it will assume those coordinates.
Yeah, I hope that answers the question.
So there's a lot to it, but
So
I hope this was very informative. Yeah.
There was a question about gingiva. I need to incorporate gingiva in the step. I assume you're talking about the model, making the model. Yes, you can put gingiva around that if you're making an implant model. Yeah, so I think that question relates to bringing the scan body and an analog into this section here, so you can make a 3D printable model.
Yeah.
Yeah.
That would follow exactly the same procedure as I've done. You're just taking the analog housing, because we've got housings, like analog housings, and then you're going to extrude it, and we've got the video in the component module.
Yeah, yeah. Excellent. I think, Michael, you've done a really great job. We're a little bit over time. So perhaps stop sharing your screen.
Yep, I want to see a few faces. So it's all good. Stop sharing.
Excellent.
Perfect. All right, we've had a good turnout tonight. Thank you for joining us. And if you've got questions, send them through to our website chat. I get a lot of questions coming through to my email and my messenger, Facebook Messenger, and I don't check them as much. So, you know, our website chat is the fastest way to communicate with us.
Excellent. Yeah.
Okay.
Awesome. Any comments or anything you guys want to add? Excellent. So
Okay.
we just want to thank you
Great
for joining.
job.
We really appreciate you supporting our cause,
Thank you.
Blenderfordental. And, you know, for tonight, from the Gold Coast of Australia, we wish you a nice day still. And it was good seeing you, and hopefully we can catch up again soon.
Wolfgang.
Yes.
Cheers, guys.
There's a question still. Is it
No,
down?
no.
Oh,
No, Wolfgang, I just want to say, there's enough room for me if I want to visit you and I can sleep on the couch.
Yes, there's space there.
And we drink good German beer as well.
So I only drink alcohol free, but I'm with you.
All
Bye-bye.
right.
Cheers.
Bye,
Bye.
guys.
Bye.